This video is on Chapter 13, Polynomials and Rational Functions. And in the notes, I gave you example 109, where I asked you to determine which of these functions were polynomials. And I gave you the solution. It was only B, but I didn't say why. And so this video is going to be an elaboration of the solution from example 109. Before I do that, though, let's talk about what polynomials are and the properties they have. So what a polynomial is, it's a function of this form. A sub n, x to the n, plus a sub n minus 1, x to the n minus 1, down to a sub 1 x plus a sub 0. What are the rules? Well, the rules are your a sub n's are real numbers. They can be anything. I wrote that in the notes. I didn't write it on the board. But what about the exponents? The exponents have to be whole numbers. So in other words, this, if it's not 0, is a natural number. It's not a fraction. It's a natural number, such as 2, 3, 4, 5. And the exponent is 0 at the end here. X to the 0 right here. We just have a sub 0 times x to the 0 for the last term. We do not want a sub n to be 0 except in one very specific case, and that's when you have the constant function. The reason for that is the degree of our polynomial is the highest exponent right here. So if this were going to a sub 0, or if a sub n is 0, and this term is not 0, then we just start here instead of here. And so the degree of our polynomial should be n minus 1 instead of n. So we don't want the lead term here to be 0, except when you actually just have the 0 function, in which case this is the 0 polynomial. Constant functions are polynomials. And so the 0 function right here is the only time where your lead coefficient will be 0. Any other time, your lead coefficient will not be 0, and this degree here determines the degree of your polynomial. So, keeping this in mind, we now look at example 109. We have 4 functions, and the question is, which of them are polynomials? Part A, we have x squared plus 3x minus the square root of x. Now, the x squared plus 3x part, if we stop there, that would be a polynomial. But the fact that we have this radical function right here, and the exponent, we can rewrite this as x to the 1/2. 1/2 is not a natural number. So, f is not a polynomial. It is an algebraic function, but it is not a polynomial, and it's not a rational function. Now, part G is part B, our function G is a polynomial. It is a 5th degree polynomial. We generally don't write 0 coefficients. We could if we wanted to. We could write x to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus 0x minus 6. There's nothing wrong with writing that, except that it kind of takes more time than we want. So other than wasting a little bit of time, there's nothing wrong with writing it that way, but as a general rule, we don't. This is a 5th degree polynomial. This function is not a polynomial. It is not, if this were x to the 3rd power, or x to the 3, it would be a 3rd degree polynomial, but it's not. It is what we call an exponential function. So we have 3 to the x. Exponential functions is something that you'll study in Calculus 2. We don't do much with exponential functions in Calculus 1. The real question you might have had, though, when you looked at the notes in Part D is, why is that not a polynomial? It looks like it might be. If you take x cubed minus x squared plus x and divide by x, well, you have x squared minus x plus 1. The problem with that is that these two functions are not the same. Why are they not the same? If we look at f the way it's written, 0 is not in the domain of the function. If you tried to substitute 0 for x, you have 0 divided by 0, which is undefined. 0 is in the domain of this function. If you substitute 0 for x here, you have 1. This part, right, this function here, this is a polynomial. It's a second degree polynomial. F itself is not. It's a rational function, but it's not a polynomial. The difference being f is not defined at 0, and the other function is. If you were to graph this function, you would graph this quadratic here, but put a hole at the point 0, 1. The point 0, 1 is on this function, but this function is undefined at 0. So to graph this, it would be this parabola with a hole at the point 0, 1. That is the only difference between these two functions, but it's a big difference. So as you're graphing this, that's the one difference in the two functions.